Hi and welcome to our lesson today. We are going to look at radicals. So radicals are numbers which have roots. Usually in radicals, our main goal is to make the number to have a perfect square. For example, a number like 4 is a perfect square. Perfect square. Then we can have the square root. Which number is a perfect square? We have started with the 4. Square root of 4 is a 2. 9 is also a perfect square. Square root of 9 is a 3. 16 is also a perfect square. Square root of 16 is a 4. 25 is a perfect square. Square root of 25 is a 5. Yeah, and so forth. Those are the square root. We can look at an example. Example 1. A number like you have been given 2 root of 48. How do you solve this? Inside the square root, we have 48. We look for two numbers which when we multiply, one will give us a perfect square. For example, to get 48, we must take, we can have 16 times 3. 16 times 3, we get 48. So 16 is a perfect square. We will use this. Then we are substituting it. We'll have 2 root of 16, then times root of 3. We are putting everything inside the roots. So this will be 2. Root of 16 is a 4. Then root of 3. 2 times 4 is a 8. So we'll have 8 root over 3. This is how we have solved our first radical. Let's look at our second radical. Our second radical is a, let's have a negative 20. That way. Again, we think which two numbers when you multiply will get the number inside the root. To get 20, we can have 5 times 4, or 4 times 5. We get 20. Then we replace everything. It will be negative. We'll have a negative root of 4 times root over 5. That way. What is the root of 4? So we are going to have negative root of 4 is 2. Then root over 5. That is what we are going to have, and that will be our answer. Let's look at another example. Example 3. And our example 3 is 1 over 8 root of 320. Root of 320. Which two numbers when you multiply you get 320? A number like 32 times 10. But in this case, we don't have a perfect square here. But if I multiply by 2, we'll have 64. Then if I divide this 10 by 2, I will get 5. When you take 64 times 5, you get 320. But 64 is a perfect square, so we are going to use that. To get 320, we are going to take 64 times 5 that way. Then we put everything inside the root. We will have 1 over 8 root of 64 also times root over 5. This will be 1 over 8. Root of 64 is just 8. Then times root of 5. We don't have the exact root of 5. We can simplify this and this. So we will have just root 5 as our answer. We will have root 5 as our answer, or 1 root 5. 1 root 5, which is just the same as root 5. So that is our answer for the question. Let's look at example 4. Let's look at another example to help us understand more. Example 4. Our example 4 for this question is have a value like -3 and 513. We want to solve this. As usual, which two numbers when you multiply we get 513? To get the number easily, you can put it inside the factor tree. 513, it is not divisible by 2, but it is divisible by 3. By 3 because of 171, then by also 3 because of 57. The two numbers can be 3 times 3, which is 9, then times 57. Yeah, then we have our perfect square there, which is 9. So we are going to use that. To get 513, we will use 9 times 57. That way. We put it inside the equation, it will be -3. It will be -3. We start with -3 first, then root of 9, then times root over 57. Put both inside the root, then this will be -3. What is the square root of 9? It is 3. Then root of 57 we don't have, so it will remain. This will be -3 times 3 is -9. -9 root over 57 is what we are going to remain with, and that is our answer. Let's go to the next step, simplifying radicals with the variables. Simplifying radicals with the variables. And we are going to start with variables are just numbers like A, B, C, D, X, Y, Z. Those are variables. Let's dive into our first example 1 already. Our first example is 7 root over 288 b power 4. Now b is our variable, so we solve this. The same concept that we have been learning. We are going to start with finding the numbers from 288. And the numbers are, check on how I'm finding it. I use a factor tree by 2 because of 144. Because 144 times 2 is 288 already. Then 144 is already a perfect square, so I'm going to use that. This is going to be 7 root over 144. Then we multiply by root of 2. That is for 288. Then root of b power 4. That way. Everything inside the root. That way. Then we continue. We will have 7. Square root of 144 is 12. So we are multiplying this by 12. And then square root of 2 is just 2. 2 remains. Then square root of b power 4 is b squared. That way. When we solve this, you can multiply 7 times 12 is 84. We will have 84 square root of 2, then b squared. We can rearrange this to bring b to the first side. It will be 84 b squared and then root over 2. That is how we have solved this question. Let's look at another question. We can have another question. Example 2. This was example 1. Example 2. And our example 2 is a -5 root of 45 n cubed. That is our second example. We solve it just like the way we have been doing before. So this is going to be, which two numbers when you multiply we get 45? We're going to start with 45. We are going to start with 45. Check on how I'm finding the numbers. By, I know 15 times 9, we get 45. But 9 is a perfect square. So this is what we are going to use. This is what we are going to use. We are going to use this. So check on how I'm writing it. To get 45, it is a 9 times 15. I put it back there. It's going to be negative 5 root of 9, then times root over 15. This in turn is going to be then n cubed. We also have n cubed, without forgetting that. We can break that down to n squared times n, or times n to power 1. That is n cubed. So I'm going to write also that as n squared, then n power 1. Everything is inside the square root, as you can see. This will be negative 5. Square root of 9 is 3. Is not square root of 15, so it remains. Square root of 9 squared. Square root of 9 squared is just 9. Of 9 squared is 9. I mean n. It will just be n. And then square root of 9 raised to power 1 is, it remains as it is. Or square root of n that way. Check. I'm going to multiply. Negative 5 times 3 is negative 15. Square root over 15 root, and then we will have n square root over n remains. I'm going to rearrange these values. So it's going to be negative 15. Then this n, I am bringing it here. This n, I'm going to bring it here. So it's going to be negative 15n. Then these two are in square root. These two are in square root. So I will just combine them into one square root. It's going to be square root over 15n. That is going to be our answer. Next concept, let's look at addition and subtraction of radicals. Addition and subtraction of radicals. Okay, so we are going straight away to look at an example. A number like negative 2 root of 12, we minus 3 root of 8, then add 3 root of 32, then plus 2 root of 27. We want to solve this question. You realize we don't have the same number inside the roots. They are all different. We are going to use the same concept we have learned to solve each. Let's start with the first one. It is negative 2. To get 12, which two numbers when you multiply we get 12? It is 4 times 3. So I'm going to put root 4 times root 3. Root 4 is a perfect square, so we will use that. That is the first part. That is the first part. So let me put this bracket so that it will help us to differentiate. Then minus 3. Which two numbers when you multiply you get 8? It is 4 times 2. So root 4 times root 2. That way, put the brackets, then plus 3. Which two numbers when you multiply you get 32? 16 times 2. So it's going to be root 16 times root 2. That way. We continue. The last value plus 2. Which two numbers when you multiply you get 27? 9 times 3 is 27. So root of 9 times root of 3. That way. We solve each independently. In the first part, it will be negative 2. Root of 4 is a 2. Then root of 3 will remain. That is the first part. The second part, it will be 3. Root of 4 is also 2. Then root of 2 remains. That is the second part. The third part is 3. Root of 16 is 4. Then root of 2 remains. Last part plus 2. Root of 9 is 3. Root of 3 remains. That is our last part. So we continue to solve it here. It will be negative 2. Negative 2 times 2 is negative 4 already. So it will be negative 4 root of 3. That is the first part. Then minus 3 times 2 is 6. So 6 root over 2 plus 3 times 4 is 12. So 12 root over 2. Then plus lastly 2 times 3 is 6. 6 root over 3. That way. Realize one thing here. We have radicals which have the same root. Let me rearrange them together. Negative 4 root of 3 and plus 6. This one here. Plus 6 root over 3. That is the first part. Then the second part we have minus 6 root of 2. Then plus 12 root over 2. That way. This is the operation we use in addition of radicals. We are going, since the roots are the same, we just add the outer values. Negative 4 plus 6. Negative 4 plus 6 is 2. So it will be 2 root 3 remains. Then minus, meaning the second part, minus 6 plus 12 is plus 2. Minus 6 plus 12 is plus 6, So plus 6 root 2 remains. So that is what we are going to have as our answer. That will be our answer. Hope you have seen how we have done it. We can look at another example on the same. Example 2. Write it down. On adding and subtraction of variables. And it is 2 root of 45. We minus root of 8, the way it is. Then minus 2 root of 32. Root of 32 that way. Then minus 2 root over 18. We are going to solve this value. We use the same concept we have learned. It will be 45 is inside the root. Which two numbers when you multiply you get 45? 9 times 5. So this is going to be 2 root of 9 times root over 5. This will be the first part. Then minus. Which two numbers when you multiply you get 8? It is 4 times 2. So root of 4 times root over 2. that is our second value, minus 2. Which two numbers, when you multiply, we get 32? 16 times 2. Root of 16 times root of 2. That way. Then lastly, 2. Which two numbers, when you multiply, we get 18? 9 times 2 is 18. So root of 9 times root over 2. This is what we are going to have. Then we solve. In the first part, it's going to be 2. What is the root of 9? It is 3. Root of 5 remains. We don't have that. That is the first part. Then minus, second part, root of 4 is 2. Then root of 2 remains. We don't have that. That is the second part. Third part, we minus 2. Root of 16 is 4. Root of 2 remains. We don't have. Then minus 2. Root of 9 is 3. Root of 2 remains. We don't have. Root of 2 remains. So this is what we are going to have. Next step, we solve each inside the brackets. 2 times 3 is 6. We will have 6 root of 5. Then minus 2 root of 2. Then minus here. 4 times 2 is 8. So 8 root of 2 minus 2 times 3 is 6. 6 root over 2. You realize one thing. We have, these values have the same numbers inside the roots. These numbers. That means we are going to have 6 root 5. Then minus 2 minus 8 minus 6. I'm repeating, minus 2 minus 8 minus 6. It is minus 16. So this is going to be, let me write the answer just above here, minus 16. Okay, let's start with the positive one. It's going to be 6 root 5. Then minus 16 root of 2 remains. This will be our answer. That will be our answer for the question. We can look at another part. Hope you have understood the concept over there already. Let's look at multiplying radicals. Now multiplying radicals. Another concept. Multiplying radicals. How do we solve radicals in multiplication? It is quite easy. We are going to start with an example. When you have 2 root of 6, we multiply it with 4 root of 5. We just multiply everything here. In this case, we are going to have 2 times 4 is 8. 8, then root over 6 times 5 is 30. That is our answer already. So you can see it is not difficult. Let's look at another example. Another example, just beside it, we have negative 3 root of 10. Negative 3 root of 10 times 6 root of 2. We are solving this. The same concept. What is negative 3 times 6? Is negative 18. 10 times 2 is 20. This will be our answer. This will be our answer. Check here. But you realize one thing here. We can still break 20. We can still break down 20 such that it will be, to get 20 is 5 times 4. So it will be negative 18 root over 4 times root over 5. That will be because root of 4, 4 times 5 is 20. So you put it inside the root in place of 20. This will be negative 18. What is root 4? It is 2. Then root 5 remains. This is going to be negative 18 times 2 is a negative 32. Root of 5 remains. So this will be our final answer. Let's look at binomials with radicals. Binomials with the radicals. Can write that down. Binomials with the radicals. We solve each and see how it's going to be. Our first example is a negative, let's start with the negative 2. In positive, let's put it as positive. So 2, and it is a root, plus root over 3. We put that inside the bracket. We are multiplying it with the 2, root 2. Then minus 5 root 3. Yeah, we want to solve this. This is a binomial with a radical. We use the concept of FOIL. First, outside, inside, last. This is going to be, check on how I'm solving it. This root 2, I multiply with everything that follows inside here. Then I will come to root 3, I multiply with the following values. So this is going to be, we start with the root 2, root over 2. We are multiplying it with the following values, 2, root 2, then minus 5 root 3. That is the first part. Then we will add, this is addition here. So plus, next value is a root 3. Root 3, I'm multiplying it with the same values, 2, root 2, minus 5 root 3, that way. Then we solve, we multiply as usual. You notice one thing here in the multiplication. This 2 root 2 and root 2 are inside the bracket. So when you multiply, it will just be root 4. So the value outside is 2, then root 4, which we are going to solve that. Then minus second part, it will just be 5. Then we multiply 3 times 2 inside the root, it will be 6. So 5 root 6. Then plus root 3. Here it will just be 2 outside, then 3 times 2 is a 6. Root 6 that way. Then minus 5. 3 times 3, root 9. This is what we are going to have. Then when we solve, it will be 2. What is the square root of 4? It is 2. Then minus 5 root 6 remains, then plus 2 root 6 it will remain, then minus 5. What is root 9? The root of 9 is 3. Put it inside the brackets. So this is going to be 2 times 2 is 4, minus 5 times, yeah, it's going to be 4. Then check here. We have these values being the same here. Like I explained before, these two values. Inside the roots, they're the same. So we deal with the values outside. Minus 5 plus 2. Minus 5 plus 2 is minus 3. So minus 3. Then root 6. Yeah, I've solved this the way it is inside the brackets. Then minus, what is 5 times 3? 15. This is going to be 4 minus 15. 4 minus 15, and then minus 3 root 6, which is going to be 4 minus 15 is minus 11, then minus 3 root 6. So we are going to have this as our this as our final answer. Next concept on the last concept on radicals, we can look at rationalizing the denominator. Rationalizing the denominator. Let me write that down. The denominator. The denominator. That way. So we are going to start right away with an example. And before the example, I will give you the golden rule. The golden rule is we multiply the fraction by a form of 1. Multiply the fraction by a form of 1. We are going to explain how that comes about. Let's use an example direct. Example 1. When you have a value like 10 divided by root 2. 10 divided by root 2. How do we solve it? I'm just going to rewrite it again so that you see. This will be 10 over root 2. We multiply it with the, hope you're seeing the denominator. I multiply it with it. So it will be root 2 over root 2. That way. In a form which when we simplify it will be 1, just like we said here. So this in turn is going to be 10 root 2. 10 root 2 divided by, what is root 2 times root 2? Is root 4. But we know what root 4 is. So it will be 10 root 2 divided by root of 4 is 2. We can simplify by 1 by 5. So our final answer is going to be 5 root 2. That is going to be our final answer. We can look at another example. Let's look at example 2. Example 2. Our example 2 is root 8 divided by root 3. This is going to be, I'm rewriting it the same, root 8 divided by root 3. We eliminate the denominator. You can see the denominator. So I will multiply both sides by root 3 all over root 3 that way. When you simplify this, we'll get 1, but we leave it that way. This is going to be, what is root 8 times root 3? Root of 24. Divide by root 3 times root 3 is root 9. Then, which two numbers, 24 we can still factor it out. 6 times 4 is 24. So I am breaking it down to root 6 times root 4. Divide by root 9. I'm going down again. This will be root of 6. Then what is root of 4? Root of 4 is 2. Then divide by, what is root of 9? It is 3. If I rewrite this, it's going to be 2 root 6 divided by 3. That will be our final answer. So we have covered all the important concepts in radicals. Hope it's now going to be easier when you're pursuing your course. Don't forget to like, share, and subscribe without forgetting hitting the notification bell for more assistance in your academics. Bye.